Imagine a metal lighter than wood in your hand, so soft that an ordinary butter knife can slice right through it. Yet the moment you drop it into water, it violently erupts or even explodes into flames. Even stranger. It serves both as a legendary psychiatric drug capable of soothing the most violent despair and mania in the human brain, and as the indispensable energy heart powering the phone in your pocket, the electric vehicle on the street, and indeed our entire modern technological civilization. What comes to mind? On the periodic table, it stands as the absolute tyrant at number 3, lithium. From the sparks of the Big Bang to the dark history hidden inside 20th century soda bottles, from the white petroleum fiercely fought over by global titans to the geopolitical chip shaping the future of human energy. Today, we're uncovering the truth behind this super metal, the lightest and most explosive element in nature, which now holds the reins to human wealth and destiny. We often use phrases like solid as a rock or hard as iron, but in the presence of lithium metal, every conventional notion human beings have about metal is completely shattered. Lithium is the solid element with the lowest density in the entire periodic table, at a mere 0.534 grams per cubic centimeter. What does that number actually mean? It weighs roughly half as much as water. Even pine wood is heavier. If you slice off a piece of lithium metal and toss it into water or oil, it won't sink at all. Instead, it floats effortlessly on the surface like a piece of styrofoam. On top of that, its crystal structure makes it extraordinarily soft. You don't need heavy industrial machinery. A simple kitchen butter knife is all it takes to effortlessly cut it in half. But don't let its soft, harmless appearance fool you. As a member of the alkali metal family, a lithium atom has only one extremely unstable electron in its outermost shell. This unique atomic structure gives it a fiery, explosive temperament. The moment it's exposed to air, lithium behaves like a hungry beast, frantically stripping oxygen and nitrogen from the atmosphere, turning from shiny silver to jet black oxide and nitride within seconds. And if you throw it straight into water, it instantly rips hydrogen from the water molecules, releasing hydrogen gas violently, along with intense heat that ignites the gas on the spot, bursting into vibrant crimson-red flames right out of a fantasy movie. To tame this dangerous rogue, chemists and industrial plants must keep it locked away in sealed containers filled with liquid paraffin or mineral oil, completely isolated from air and moisture. This striking paradoxical nature, lighter than water, soft as butter, yet wildly explosive, meant that from the very moment lithium was discovered, it was destined never to stay in the shadows. Yet surprisingly, long before this volatile metal was harnessed for industry, it first carved out a bizarre chapter in human psychiatry and consumer history. If you were to ask a psychiatrist, their immediate thought upon hearing lithium wouldn't be batteries at all. It would be lithium carbonate. The story dates back to 1949, when Australian physician Dr. John Cade unexpectedly discovered during experiments that lithium salts could miraculously calm highly agitated lab animals. He went on to apply lithium salts to psychiatric care, proving that lithium ions possessed an astonishing soothing effect on bipolar disorder. To this day, even though medical science has not fully decoded the exact mechanism of lithium ions deep within the human brain, lithium carbonate remains globally recognized in psychiatry as the gold standard treatment for bipolar disorder. Trace amounts of lithium ions can cross the blood-brain barrier, replacing sodium ions in neurons and directly intervening in neurotransmitter signaling, pulling patients back from the brink of mania and despair. Even more bizarrely, in the early 20th century, this brain-stabilizing element took the food and beverage industry by storm. In 1929, a soft drink named bib-label lithiated lemon lime soda was launched in the United States. While the name sounded heavily academic, it was actually the predecessor to today's household brand, 7-Up. Advertisements back then claimed, "It takes the ouch out of grouch," because its original recipe truly contained lithium citrate. It wasn't until 1948 that the U.S. Food and Drug Administration officially banned lithium in soft drinks due to concerns over toxic side effects from excessive intake. Only then was 7-Up forced to alter its formula and erase this dark piece of history. Who could have guessed that a trace element capable of stabilizing the human mind would, decades later, end up stabilizing an even grander titan, modern industrial civilization? Toward the end of the 20th century, human society witnessed an unprecedented mobile electronics revolution, pushing lithium directly to center stage. Out of the more than 100 metals on the periodic table, why did lithium become the undisputed star of battery technology? The answer lies in two extreme physical traits: exceptionally low mass and an extraordinarily high electrochemical potential. As the lightest metal, lithium has a relative atomic mass of just 6.94. At the same time, it boasts a standard electrode potential of -3.04 V, meaning that, pound for pound, lithium can store and release far more electrical energy than almost any other metal. Between the 1970s and 1980s, three visionary scientists, John Goodenough, Stanley Whittingham, and Akira Yoshino, cracked lithium's energy code and invented the world-changing lithium-ion battery. Their breakthrough earned them the Nobel Prize in Chemistry in 2019. The operating principle of a lithium battery is remarkably elegant, often referred to as a rocking chair battery. When charging, lithium atoms release electrons to become lithium ions, migrating through a separator to embed into the negative electrode. During discharge, the lithium ions rock right back to the positive electrode. Every time you light up your smartphone, work on a laptop, or drive an electric vehicle down the street, you are essentially witnessing trillions of lithium ions shuttling back and forth inside this microscopic rocking chair. From Sony's commercialization of the first lithium battery in 1991, to Apple launching the smartphone era, to Tesla igniting the electric vehicle storm, lithium batteries untethered electronic devices from power cords, ushering human civilization into a new age of mobile connectivity and clean energy. And so, lithium completed its grandest transformation, evolving from a hazardous chemical into the pulsing energy heart of modern technology. As lithium became the cornerstone of electric vehicles and grid-scale energy storage, it ceased to be merely a metal. It became the white petroleum of the 21st century. At the intersection of Chile, Argentina, and Bolivia in South America lies an arid high-altitude plateau known as the Lithium Triangle, home to more than half of the world's lithium brine resources. Pumping mineral-rich brine from deep underground, workers let it evaporate under the scorching sun for months or even a year, using complex chemical precipitation to ultimately extract snow-white lithium carbonate. Tesla CEO Elon Musk famously quipped in public, "Refining lithium is basically like printing money." Over recent years, as the global shift toward clean energy exploded, lithium prices underwent breathtaking spikes and wild volatility. The price of battery-grade lithium carbonate once surged to hundreds of thousands of yuan per metric ton. This massive profit incentive ignited a fierce global resource scramble between mining giants and automakers, stretching from Australian hard rock spodumene mines to South American salt flats. Yet behind this frantic lithium rush lies a heavy environmental cost that cannot be ignored. In the bone-dry Atacama Desert, extracting a single ton of lithium requires pumping and evaporating thousands of tons of subterranean brine, severely disrupting fragile local ecosystems and underground water tables. On the other hand, uneven resource distribution and highly concentrated refining supply chains have turned lithium into a sensitive strategic asset in global geopolitics. Whoever controls lithium deposits and refining technology holds the key to the next energy revolution. Yet even now, one of the deepest mysteries surrounding lithium remains its origin at the dawn of the universe. According to modern astrophysics, lithium was one of the first three elements born in the first few minutes after the Big Bang 13.8 billion years ago, alongside hydrogen and helium. However, when astronomers observe stars throughout the cosmos, they find that older stars contain far less lithium than predicted by Big Bang theory. This is the famous cosmological lithium problem. Born in the creation of the cosmos, destroyed deep inside stars, it ultimately found its way to Earth to drive the wheels of human technological civilization. Today, facing lithium supply constraints and recycling challenges, scientists are aggressively developing next-generation technologies, such as sodium-ion batteries, which leverage abundant, low-cost materials, and all-solid-state lithium batteries, which ditch flammable liquid electrolytes for unparalleled safety and doubled energy density. The forms lithium takes may evolve, but humanity's pursuit of ultimate energy and a clean future will never stop. From Stardust formed 13.8 billion years ago to the phone resting in the palm of your hand. This is the legendary story of element number 3, lithium. If you enjoyed this deep dive science video, please be sure to hit like, share, and subscribe to the channel. Let me know in the comments, do you think sodium-ion batteries will completely replace lithium batteries in the future? See you next time.